Today we will be going over Leetcode 135, candy. In this problem, we have some people, and each person has a rating. And we need to distribute some candy to these people. Each person must have at least one piece of candy, and each person with a higher rating than their neighbor must have more candy than that neighbor. In an ideal situation such as this, we could just iterate through and give an additional piece of candy to those with a higher rating. So let's take a look at the answer we arrived to in the first animation. In this instance, we have a special case where each number that is greater than its neighbor is greater than both neighbors. So if we look at this like a graph, it would look like that. And for this guy. So this one we can solve very easily with one pass. So everyone gets their initial single piece of candy. And then let's just say we're going to look at our previous neighbor, the neighbor on our left. So 7, there is no neighbor. 11, it's greater than the left neighbor. 3, it's not greater than the left neighbor. 4 is greater than the left neighbor. 2 is not greater than the left neighbor. So 1, 2, 3, 4, 5, 6, 7. 7 is our answer. And we did it with one pass. Now let's take a look at another case where each number that is greater than the left neighbor is not greater than the right neighbor. We're going to do the same thing. We're just going to check the left neighbor. So let's give everyone their initial piece of candy. One's left neighbor is out of bounds. Is 2 greater than 1? Why, yes, it is. So we'll give him an extra piece of candy. Is 3 greater than 2? Why, yes, he is. Is 4 greater than 3? Why, yes, they are. 5. So now each person has been given an additional piece of candy, but we can clearly see that this is not correct, right? Because 2 is greater than 1, yes. 3 is greater than 2, but they have the same amount of candy. Let's take a look at another example. Once again, we're just going to do one pass from the left, and we're going to check if they're greater than their left neighbor. Okay, it's 5. No, it's out of bounds. 4. No, 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 no. All right, so a single pass isn't always going to be the answer. Now let's iterate through this way, checking the right neighbors. Is 2 greater than 1? Why, yes, it is. Is 3 greater than 2? Why, yes, it is. Is 4 greater than 3? Why, yes, it is. And is 5 greater than 4? Yes, it is. So we ran into the same problem here, right? So what does this say? What is this telling us? Well, we can't just increment by 1. So now we've discussed some issues we might have. Let's start writing some code. The first thing we're going to do is we're going to create a result array. And the result array is going to be an array where all the values are equal to 1. And we're just going to time multiply it by the number of people we have. So our list, whatever the parameter name that Leetcode gets it. And now we're going to do our first iteration through and distribute the candy as necessary. But let's remember, each person starts with a single piece. So that's what our array is representing. The amount of candy per person, where the index is the same index that they are in the parameter that's given to us. So let's start our iteration. So for I in range, and remember where we're going to start? We're not going to start at the very beginning. We're going to start at the second person, and we're going to compare to our left neighbors. So 1 to the length of people. And what are we going to do? Well, we're going to see if people, I'll just abbreviate as P, at index I is greater than P at our left neighbor, so I minus 1. Then remember what we are going to do? We are going to set the value at P, or our result, equal to the previous neighbor's count of candy plus 1. So that way we'll have more candy than our previous neighbor. So result at index I, oops, result, nope, that was correct. Result at index I, we're going to set to result at index I minus 1 plus 1. So let's go ahead and do that. Okay, so starting here, are we greater than our previous neighbor? Yes. So we're going to take 1 plus 1 and set it here. Now 5, is that greater than 4? Yes, it is. Are we going to increment? No, we're going to take the previous value, which is 2, and increment that. So our new value is 3. Is 2 greater than 5? No. Is 7 greater than 2? Yes. So we take that value from our left neighbor, increment it by 1, and set that to our value there. Now we're going to increment from the end to the beginning. So this is our second pass. So for j in range, and we want to start not at the final element, which would be the length of people minus 1, but the next one. So we are starting at the length of people minus 2, and then to iterate backwards in Python, just minus 1, minus 1. And so we're checking the same thing. We're going to say if people at index j, but instead of doing the left neighbor, we're going to do the right neighbor. So if it's greater than j plus 1, then what are we going to do? Well, we're going to update our result at index j. So res at index j becomes, now what are we going to do there? Because we realized that incrementing wasn't always the best thing. And also setting it to this value plus 1 is not the best thing, because this is already at 3. So if we set it to 1 plus 1, that's setting it to 2, that's lowering it, and it's throwing off our results. So what we're actually going to do is we're going to do the max of those two options. So either its current value, so the result at index j, or the result at j plus 1 plus 1. And at the very end, we just need to get a total of our result. So we can set another variable. We can say total equals the sum of result. And then we can just return. Sorry, that went a little out of bounds there. We can just return our total. So now let's head over to the IDE, write this out, and see how Leetcode likes it. Okay, so let's go ahead and write our code now. We have to initialize a result array. Remember, it's one piece of candy minimum for each person. So the length of ratings. And now we're going to do our first pass. So for I in range, starting at index 1 to the length of ratings, if ratings at index I is greater than our left neighbor, so ratings at index I minus 1, then we need to set the value of our result at I to the value of the left neighbor plus 1. Now for our second iteration, starting from the end, for j in range, and remember, we have to start at the end, which is not the length of ratings. If we wanted to start at the final element, it would be length of ratings minus 1. But remember, we're comparing to our right neighbor. So we need to start at length of ratings minus 2. And we're going to iterate all the way through to the beginning. So if ratings at index j is greater than its right neighbor, so ratings at index j plus 1, then we need to set the result at index j equal to, remember how we did this? We need to take the max value of our result at j, because it could already be greater than, or our result at j plus 1 plus 1. Now we can get our total, which is going to equal the sum of all the values, sum of all the values in our result, and then we return our total. Now let's run this. And you can't see it, but Leetcode is very happy. And we have done this with 2 iterations through our array. which is big O of n time complexity. And we had one data structure, our array or our list of length ratings. So we did it in also big O of n space complexity. Was higher than both neighbors. So 4 is greater than 3, and 4 is greater than 2. All right, Bill, stand up there. Come on, buddy. Okay. And then we'll have this one be higher. Bill, you're fired. Queel, you're in.